potential due to a point charge. I want to calculate the value of the electric potential created by a point charge. Let's say we have this positive point charge, and I need to calculate the potential created by this charge at the point P. We said before, without calculation, Vp equals to K Q divided by R. Okay? I need to calculate this relation. Here we have Q charge. You know, as we have a positive charge, the electric field must be outward in this case. You know the relation exists between the electric potential and the electric field. Delta V equals to V final minus V initial equals to minus integral initial to final E dot dr. Okay, this is a general relation. You can use it without calculation. Okay, now I need to precise where is the initial, where is the final point. This is the most important point to find the point. As you know, you have a point here, P. P, it can be the initial position or it can be the final position. Okay, let's say here we have this point as initial and we have a point at infinity at the final point. Why I take a point at infinity? Because I know the value of the electric potential at infinity equals to O. Okay, so if V final equals to 0, because it's V infinity minus V initial at the point P, I can calculate the value of Vp. So it's important to find a position where you know its value as the infinity position. Okay, so I take the initial position at P, we can say initially at P, and finally at infinity. Here I am talking about the distance. So let's take P is at a distance equals to capital R. Okay, so dr or R is between the initial position capital R and the final position is infinity. Okay, let me write a new equation. We can say here V final is V at infinity minus V initial is V as a point P equals to minus E dot dr. R at the point P equals to capital R and at infinity equals to infinity. Here you put the distance from the charge at the point. At the point P, this is the distance. At infinity, we have an infinity distance. Okay, you know, dr here is from the point P to infinity, okay, in this direction. Because I take dr from the distance r to the distance infinity. This is the distance of the position of r is here, and here we have the position infinity. Small dr, it must be like this, a small displacement, small dr, from this point to this point. Okay. You know, E is out because it's a positive charge. So at this point P, E also must be out. Okay, now the important point here that dr must be directed from the position of this point to the position of this point. Okay, as you see, from the point P to the infinity. I repeat because it's important. Okay, the angle between E and dr equal to 0. So here we have minus r to infinity E dot dr times cosine the angle between equals to minus E, you know, the field created by a charge equals to K Q absolute value divided by the distance square. Okay, the distance between the point and the charge. Here, in this case, I take any value, okay, because it may be, it must be between P and infinity. At this point, at this point, and at this point, at any point, we can say the arbitrary point is R. Okay, so E at any point between P and infinity equals to KQ divided by R square times dr equals to minus K is constant, Q is constant, and we get inside integral of minus 2. We put R square here, minus 2 dr. So, you know, the integral of x dx equals to x1 plus 1. Here we have, if we have a, equals to a plus 1 divided by a plus 1. Here a equals to minus 2. So we get the value equals to, don't forget the limit between r and infinity, equals to r minus 2 plus 1 divided by minus 2 plus 1. Between r and infinity equals to minus 2 minus 1, minus 2 plus 1 equals to minus 1, minus 1 times minus equals to plus. K Q, here we have R power minus 1. Okay, between R and infinity. Let me continue here. So V infinity minus Vp equals to K Q. We can put 1 over R between R and infinity equals to K Q 1 over infinity minus 1 over R. Okay? So V infinity, equals to O. So minus Vp equals to minus KQ divided by R. So Vp equals KQ divided by R. Like this, we can calculate the electric potential at the point P equals to KQ divided by R. This is the calculation of the electric potential at any point due to a point charge. The important point here is if Q is positive, so if Q is positive charge, the electric potential V must be positive. If Q is a negative charge, so V must be negative. We can say the negative charge will create a negative electric potential, and the positive charge will create a positive electric potential.